Poka yoke is a Japanese term that means mistake proofing or inadvertent error prevention. A Poka yoke is any mechanism in a process that helps an equipment operator avoid mistakes and defects by preventing, correcting, or drawing attention to human errors as they occur. The concept was formalized and the term adopted as part of the Toyota production system. A simple Poka yoke example is demonstrated when a driver of the car equipped with a manual gearbox must press on the clutch pedal prior to starting the automobile. The interlock serves to prevent unintended movement of the car. Another example of Poka yoke would be the car equipped with an automatic transmission, which has a switch that requires the car be in park or neutral before the car can be started. These serve as behavior shaping constraints as the action of the car in park or the foot depressing the clutch or brake pedal must be performed before the car is allowed to start. The requirement of a depressed brake pedal to shift most of the cars with an automatic transmission from park to any other gear is yet another example of a Poka yoke application. Over time, the driver's behavior is conformed with the requirements by the repetition and habit. Poka yoke can be implemented at any step of the manufacturing process where something can go wrong or an error can be made. For example, a fixture that holds pieces for processing might be modified to only allow pieces to be held in the correct orientation, or a digital counter may track the number of spot welds on each piece to ensure that the worker executes the correct number of welds. A typical feature of Poka yoke solutions is that they don't let an error occur. Other advantages include less time spent on training workers, elimination of many operations related to quality control, unburdening of operators from repetitive operations, promotion of the work improvement-oriented approach and actions, a reduced number of rejects, immediate action when a problem occurs, 100% built-in quality control, preventing bad products from reaching customers, detecting mistakes as they occur, and, naturally, eliminating defects before they occur. A checklist is a type of job aid used to reduce failure by compensating for potential limits of human memory and attention. It is a form of error proofing that helps to ensure consistency and completeness in carrying out a task. While a basic example of a checklist is the to-do list, a more advanced checklist would be a schedule which lays out tasks to be done according to time of day or other factors. A primary task in many checklists is documentation of the task and auditing against the documentation. Checklists have been used in the healthcare practice to ensure that clinical practice guidelines are followed. For example, in the WHO Surgical Safety Checklist developed by the World Health Organization, it was found to have a large effect on improving patient safety. However, excessive dependence on checklists may hinder performance when dealing with time-critical situations. For example, a medical emergency or an in-flight emergency. Checklists should not be used as a replacement for basic common sense. Intensive training, including rote learning of checklists, can help integrate use of checklists with more adaptive and flexible problem-solving techniques. In manufacturing, the term ANDIN refers to a system which notifies managerial, maintenance, and other workers of a quality or processing problem. The alert can be activated manually by a worker using a pull cord or button, or it may be activated automatically by the production equipment itself. The system may include a means to pause production so the issue can of course be corrected. Some monitored alert systems incorporate audio alarms, text, or other displays. However, stack lights are among the most commonly used today. An ANDIN system is one of the principal elements of the Jidoka quality control method pioneered by Toyota as part of the Toyota production system, and it is therefore now part of the lean production approach. It gives workers the ability and moreover the empowerment to stop production when a defect is found and immediately call for assistance. Common reasons for manual activation of the ending cord are part shortage, defect created or found, tool malfunction, or the existence of a safety problem. Work is stopped until a solution has been found. The alerts may be logged to a database so that they can be studied as part of the continual improvement process. The system typically indicates where the alert was generated and may also provide a description of the trouble. Modern end-in systems may include text, graphics, or audio elements. Audio alerts may be done with coded tones, music with different tunes corresponding to the various alerts, or even pre-recorded verbal messages. Screening is a form of error proofing commonly used in the human resources sector. It is a process used to determine a job applicant's qualifications and potential job fit for a position to which they have applied. The pre-screening process typically begins with a review of the candidate's employment application and resume, followed by an interview. A recent trend among many organizations is to use the candidate's social networking profile as a tool in the screening process. The purpose of an employment application and resume review is to screen out applicants who do not meet the basic requirements for a position. While technology has radically changed this step for those using applicant tracking systems, many HR practitioners still screen each resume or application manually. Poka Yoke is a technique for avoiding simple human error in the workplace. Also known as mistake proofing, goof proofing, and fail-safe work methods, Poka Yoke is simply a system designed to prevent inadvertent errors made by workers performing a process. The idea is to take over repetitive tasks that rely on memory or vigilance and guard against any lapses in focus. Poka Yoke can be seen as one of the three common components of zero-defect quality control, which is performed by Japanese companies. But it does not just prevent defects in the product, but also adds a level of safety to a process. For example, you have probably seen a molding or stamping machine that requires the operator to press two buttons, which are so far apart it requires both hands. The objective is to make it impossible for the operator to have a hand in the wrong place and get injured. It eliminates safety hazards. Every week, we upload new videos between 5 and 10 minutes in length, where we will focus on the strategic implementation of Lean and Six Sigma. As a Six Sigma expert, I am passionate about quality. And if you are too, then click subscribe to be notified whenever we upload our next Lean Six Sigma video.